If you've ever looked up at the sky and asked questions, then you're an astronomer. You're doing something people have done for thousands of years. Many say that astronomy is the oldest of the sciences, an attempt to explain the nature and the movements of the stars. And few areas of science can show us more clearly just how radically our ideas and our understanding can change over time.
The sun rises and sets every day like clockwork. But how do we know whether it's the sun that's circling around the Earth or the Earth itself that's rotating? From here on Earth, visually, both would look exactly the same.
It's not just the sun that moves either. Take the night sky. Like the sun, the moon rises and sets. And if we look at the stars, they all too appear to move, rotating around a single point. Again, there are two possible explanations. Either the stars or the Earth itself must be moving.
For the ancient Greeks, the answer was simple. The sun and stars had to be moving, not the Earth. If the Earth was moving, wouldn't we feel it moving? The ancient Greeks therefore built a model to describe their understanding of the way the heavens moved. They placed the Earth at the center, with the moon and the sun orbiting around. And the stars were fixed to a distant celestial sphere, itself rotating around the Earth. Everything moved in perfect circles, a symbol of the God's perfection.
But there was a problem with this system. In Greek, they called them planetos, meaning wanderers. These objects moved back and forth across the night sky. They didn't cooperate. They didn't fit the model.
To account for these wandering stars, the Greek model had to be modified. Convinced that the heavens moved in perfect circles with a fixed Earth at the center, astronomers developed ever more complex models to account for what they saw. Circles upon circles upon circles.
But then there came an alternative model. A model proposed in the 16th century by the Polish astronomer Nicolaus Copernicus and later perfected by the German Johannes Kepler, placed the sun and not the Earth at the center.
Here I have the sun, Earth and Mars, with the sun at the center of the solar system and the Earth and Mars orbiting around it. Now, if I was on Earth and I took photos of Mars night after night against a background of fixed stars, let me show you what you'd see.
We see just what the ancient astronomers saw. Mars moves forwards and backwards across the sky. The planet does not really change direction. It is simply how we view it from the Earth against a background of stars. Those wandering objects we now know were not stars themselves, but planets. And this elegant, sun-centered solution could explain away the need for the old model's never-ending circles. Then, in 17th century Italy, the astronomer Galileo Galilei did something unprecedented. He built a telescope and he pointed it at the night sky. One of the many groundbreaking discoveries that Galileo made with his telescopes was that the planet Jupiter appeared to be host to 4 moons of its own, the first direct evidence that not everything revolved around the Earth. Our place in the cosmos was no longer special. In this new model, the planets orbited around the Sun, and this meant for the Sun and stars to move across the sky, the Earth must be rotating. Here is a clear example of how science works. Scientists use models that can explain what we see and experience, models that can predict how things will behave in the future. If a new model can better explain what we see, then it replaces the old. Of course, we've come a long way since Galileo first pointed his telescope. Nowadays, they've grown a little bigger. Telescopes like the Liverpool Robotic Telescope and the giant William Herschel Telescope, located alongside many others on the island of La Palma in the Canary Islands, high above most of the clouds. With telescopes like these, the planets that caused the Greeks so much trouble are revealed in all their wondrous beauty. We can now see them in glorious detail. We now know that some of those pinpricks of light we see are not planets or stars, but entire galaxies, each made up of billions of stars, and that we are just one of billions of such galaxies stretching across a cosmos that is larger than the ancients could have ever imagined. We've put telescopes into space, giving us a new perspective on the universe. We've sent probes to other planets and even observed the sunset on Mars.
Better tools means better evidence, and this helps us develop better theories of how the universe works. The oldest of the sciences has come of age, and there's never been a better time to be an astronomer. Of course, there are some people who say that what we have learned has shown us that we and our planet are insignificant on the vast scale of the cosmos, but as far as we know, we're the only planet that's trying to understand how the universe works, and for me, that makes us special.